Electricity usage in the home. So what we're going to be doing is just really basically looking at how we can use all the mathematical knowledge that we've developed over the last 5 years and roll it into this thing called electricity usage in the home. So first up, we're looking at a sector graph. And this sector graph shows how much electricity is used in an average Australian home. And it says calculate to the nearest degree the angle size of the cooking sector. Well, from up here, you can see that the cooking sector is 5%. And we know that in a circle, all the angles add up to 360. So I'm going to multiply by 360 and I'm going to get 18 degrees. So if I was asked to draw this sector, I would know that I would draw a sector that had an angle in the middle of 18 degrees. So what is the area consumed by most electricity in the home? Well, this is simply just by looking at the graph. Which one is the most? It's heating and cooling. So that's an easy one. If the cost of household electricity was $978.58 for the November to February quarter, how much was spent on heating and cooling? Now, electricity, you may or may not is always measured in quarterly bills. How much was spent on heating and cooling? Well, we know it's 40% of the bill. So if I do 40% of that $978.58, and I pick up my calculator, and I get 391.432. And remember, we always write our unrounded decimal first. And then in my next line, I write my rounded number, and remembering money has 2 decimal places, so $391.43. The next question is, what could be included on other appliances? Well, other appliances could be anything. Dishwasher, iron, TV, anything at all along those lines. Leading us into the last question, if the cost of other appliances for one bill was $58.50, what was the total electricity bill? Well, we know from the graph that other appliances is 14%. So I'm going to say that 14% must be equal to $58.50. And you can see where we're going with this, the same thing we always do. Our unitary method, we're going to get 1%. And we know that the whole bill is 100%. So we know that we're dividing by 14 and we're going to multiply by 100. And what I do to one side, I must do to the other. And this other side is the side that's going to give me my answer. So if I do all of that, 58.50 divided by 14 divided by, that should be times by 100. And what I get is 417.857, etc. And we need to round this to 2 decimal places because money all has 2 decimal places. So that's 86. So $417.86. So now that we've looked at some statistics, what we're going to do is we're going to look at how power and energy is measured. And it's measured in the watt, with this measurement with a capital W. And it's a unit of power and it's equal to 1 joule of energy per second. Now here is a scary looking table and it talks about the different things. So if I've got watts, smaller than watts is a milliwatt, smaller than that is a microwatt. Greater than a watt is a kilowatt. Then I have a megawatt, a gigawatt, a terawatt, and we even have a petawatt. Now, looks scary, but it isn't really. So what we always start with is we start with our watt, and then I know I've got kilowatts, megawatts, gigawatts, and terawatts. And on the other side, I've got milliwatts and microwatts. And the good thing about these conversions, even though this table looks scary, is that everything's 1,000. So all I'm doing is multiplying everything by 1,000 to convert from one unit to another. And then equally, to convert from the smaller unit to the bigger unit, we're going to be dividing by 1,000. And that makes life a lot easier. So now I know that electricity usage is measured in watt hours. So electricity for an appliance is watt, and the usage is measured in watt hours. which is the amount, this is the amount of electrical energy used by 1 watt load, such as a light bulb, drawing power for 1 hour. And the energy for household bills, because we use more than watts, is kilowatt hours. And that's equal to 1,000 watt hours. And the cost of electricity usage is given in cents per kilowatt hour. So, looks scary, but it's really very simple. So let's have a look at these examples. Convert 8,350 watts to kilowatts. So in order to do it, I've got 8,350 and I've got watts. And all I'm going to do is I'm going to divide that by 1,000 to change it into kilowatts. And if I do that, I get 8.35 kilowatts. So for part B, I'm going to do the same. I've got 35,000 megawatts, and I need to convert that into watts. So that's got to be 35,000, one too many zeros. I'm going to multiply that by 1,000 to change it into kilowatts, and I'm going to multiply by 1,000 to change it into watts. And what your calculator will give you, it will give you an answer, I think, in scientific notation, which is 5.3 times 10 to the power of 10. So looking therefore at part C, I've got 152,000 gigawatts, and I want to convert that into kilowatts. So what I have is I need to multiply that by 1,000 to change it into megawatts, and I have to multiply it by 1,000 again to change it into kilowatts. And that's going to give you an enormous number as well. And I'm going to write that as 1.526 times 10 to the power of 11. Now, power is measured as domestic power and off-peak power. So domestic electricity is the amount of electricity that we use during the day, and off-peak electricity refers to electricity that's used late in the evenings and early mornings. So say between 10 p.m. and 7 a.m. when demand from households and businesses is much lower. And off-peak electricity is charged at a much cheaper rate than domestic electricity. So let's have a look at a question where we can try and work out what the cost of an appliance running is going to be. And this question says, calculate the cost of electricity usage for a household where domestic usage is 954 kilowatts at, and here we go, our money is always given to 6 decimal places. So cost is 0.284500 kilowatt hours. And the off-peak usage is 784 kilowatt hours at, and it's got a much cheaper rate of 0.099. So cost of domestic usage is equal to 954 times that 0.248500. So it's 271.413, and I'm going to leave it in the unrounded form because I only want to round once, and that's at the end. Cost of off-peak usage is 784 times 0.0993970, and that gives me 77.90608. So the total cost, I'm going to add those two together, 271.413 and 77.90608. And I get my unrounded answer, which I'm going to write down as 349.319, etc., which rounds to $349.32. And that's all there is.